these reactions are redox reactions. The thing is, it's just not showing the other element. Sodium as an ion does not exist by itself. It has to be neutralized by another element, and same with this magnesium ion. But that's okay. We can still look at them as redox reactions. Since they're redox reactions, remember that we learned that a more active element can only replace a less active element. And this is an activity series for metals. And on a metal, what makes a metal more active? Is a more active metal more likely to become an anion or a cation? Does a more active metal tend to give up electrons or tend to keep or accept more electrons? Metals are known for giving up electrons, and the more active the metal, the more likely it is to give up electrons. So they become cations. Okay, so since we know that, let's look at one of these reactions at a time. Magnesium, we're going to put the oxidation numbers on here. Magnesium is neutral here, so its oxidation number is 0. Same here with sodium. The charges is what we use on these. Okay, so in this first reaction, what's happening? Which metal is giving up electrons? It looks like magnesium is giving away electrons because it's becoming more positive. Okay, that's what an active metal does. So here's magnesium. Okay, then let's look at sodium. And the problem is, sodium is gaining electrons. And that's not what active metals do. Here's sodium. Sodium is more active. So in other words, magnesium will not give electrons to sodium. It's too active. So magnesium can only give electrons to metals less active than it. It will not give them to sodium. Let's look at the next reaction. I'm going to erase a little bit here. Okay, on the next one, we kind of have the same thing going on, but we have aluminum being the one that gets the electrons from the magnesium. So magnesium's giving up electrons, which active metals do. The question is it more active than aluminum? And it is. It's above it on the activity series. So a metal Okay, so the first reaction we said would not occur, and the second one will. Another way to say that, when we have two metals, the one that ends up the most positive, with the losing the most electrons, ends up the most positive, will be the more active metal. So in the first case, that wasn't true of magnesium and sodium. Magnesium was trying to end up being more positive, or a cation, and that won't happen because sodium is more active. In the second one, we have magnesium again acting to become a cation, and it is more active than aluminum, so the second one will occur. This is the opposite for nonmetals. For nonmetals, the more active will accept from less active nonmetal. So in other words, nonmetals tend to become anions. Active metals become cations, active nonmetals become anions.